In this video, we're going to look at how to solve trig equations. Trig equations are equations with trigonometric functions in them, sine or cosine usually, like the ones shown here. The important thing to notice is that any trig equation question is going to have two parts, the equation itself and then the domain on which you're asked to find solutions. And that's going to be important. You're going to need to look carefully at the domain in the question because if the domain is given in radians, that means your answer is expected in radians. And all of the examples in this video are going to be in radians. The domain is also going to determine how many solutions you have because it sets the limits on what your answers can be. And we'll see that as we go through the examples. We're going to look at how to solve trig equations both algebraically and using your graphing calculator. And we're going to start with algebraically. So we're asked to solve for x where 2 sine x is equal to -1 and where x is between 0 and 2 pi inclusive. Now note in the video we're using x for the principal angle throughout, but you could alternatively use theta if that's what you prefer. Just replace all of the x's with thetas throughout. So to get our way into the x here, we need to work our way in one step at a time. First thing we're going to do is divide both sides by 2 and we get sine x is equal to -1/2. And then in order to undo this sine function on the left, we're going to take the inverse sine of the left side, which means we need to do the same thing on the right side. This is a step that you won't often write down, but I'm going to do it here just so it's clear what operation is happening. Now the inverse sine of sine x is simply x, so the left side becomes x, and the right side is the inverse sine of -1/2. So now the easiest way to think of this is to find the related acute angle first. And if we let alpha be the related acute angle, RAA for the related acute angle, then alpha is going to be equal to the inverse sine of +1/2 because that's going to push this angle into the first quadrant and drop the negative sign. We recognize that as one of our special triangles. The inverse sine of 1/2 is 30 degrees, or if we're working in radians, it's equal to pi/6. If you're having trouble with that, you might want to review one of the earlier videos. Now that we've got that, we need to put our pi/6, our 30 degrees, in the correct quadrant in order that sine of our principal angle is negative. Now, by the cast rule, or thinking of sine as y/r, we recognize that that means we're in one of the bottom two quadrants. So we place pi/6 here and pi/6 here to be our related acute angles. And now we ask, what's the principal angle? Well, if we're between 0 and 2 pi, that means we're starting here from our positive x-axis and going counterclockwise to there, and that's pi plus another pi/6. That's a principal angle of 7 pi/6. So x is equal to 7 pi/6. We've also got another one, however, that we're going to cross before we get to 2 pi, our end boundary. So if we go around all the way to here, we've gone around 2 pi, but now we have to go back to the line here, which is pi/6 back. That means that our principal angle there is 2 pi minus pi/6, and that's 11 pi/6 because 2 pi is 12 pi/6. Just getting a common denominator. So our second answer then is 11 pi/6. Again, we found the related acute angle. We drew it out using either the cast rule or the definition of sine x or sine theta as y/r. And then we worked out that our two angles were 7 pi/6 and 11 pi/6. Now let's make things a little bit more complicated. In this question, the domain that we're given is not 0 to 2 pi, but it's -2 pi to 4 pi. And that brings up the point that in trig equations, you need to watch the domain and add or subtract multiples of 2 pi to get all the appropriate values for your answer. You'll see what I mean in a moment. The beginning of the question is exactly the same as we saw before. We're going to divide both sides by 2, and once again, we get sine x is equal to -1/2. Again, we're going to take the inverse sine of both sides so that x is equal to the inverse sine of -1/2. But this is the part where the question starts to differ, because although solving that, we are going to get our answers of 7 pi/6 and 11 pi/6 as we did before, there's going to be other answers as well. And let's draw a diagram to see why that's the case. This was the diagram that we drew a moment ago when solving the similar question that only differed in its domain. And we found that our principal angles were 7 pi over 6, and going all the way around to here, 11 pi over 6, because we went 2 pi and then back pi over 6. Now, that is all the angles that we're going to get if we start from 0, go round to pi, and then round to 2 pi. But the question is asking us to go round again to 4 pi. Remember, 4 pi is 2 full rotations, and it's asking us what other angles we're picking up as we get to there. That means we're going to hit this line and this line again. In other words, there are 2 more angles that are coterminal with 7 pi over 6 and 11 pi over 6 that we're going to get to before we get to 4 pi. Well, what are those angles? Let's think of it from the start. If we start at 0, we go round once to 2 pi. On that trip, we've picked up the 7 pi over 6 and the 11 pi over 6 angle. If we go around again, we get to 3 pi. This angle here, which was pi on the first go around, is now 3 pi, 2 pi more than that. And then to pick up this angle here, we have to add another pi over 6. Well, 3 pi with a denominator of 6 is 18 pi over 6, plus another 1 pi over 6. That gives us 19 pi over 6. Then if we keep going, we go around to 4 pi, and then back pi over 6. 4 pi with a denominator of 6 is 24 pi over 6, minus another pi over 6, because we get all the way around and then have to come back, is going to be 23 pi over 6. Notice that these angles are less than 4 pi, so they still fit within the domain of the answers we're being asked to pick up. Another way also of thinking of these is notice that we've just added 2 pi to the answers that we got initially. These were the answers from the first version of the question. Now we've added 2 pi to get the next angle coterminal with each of these. So that's another approach you could think of it as being, instead of drawing the picture, we're just adding 2 pi each time. We haven't finished yet, though, because the question actually didn't ask us to start from 0. It asked us to start from negative 2 pi. In other words, we need to go to 0 and go backwards clockwise a full revolution and ask which angles we're going to pick up there. Well, if we start from 0 and we go this way, the first one we're going to pick up is going to be negative pi over 6. And then the second one, we would go round to negative pi, and then back pi over 6. Negative pi with a denominator of 6 is negative 6 pi over 6, plus pi over 6, that's negative 5 pi over 6. Once again, notice that we could have generated either of those angles by taking the ones we started with and subtracting 2 pi, or subtracting 12 pi over 6. So now you can see that without actually changing the equation part of the question itself can become a little bit more complicated by changing the domain on which we want answers. The key there is to think about adding or subtracting multiples of 2 pi to pick up all the appropriate values on the domain that you're asked for. Now we're going to change the function slightly to illustrate another point, and that's the point that sometimes you need to change the domain of the question that you're given in order to match the input of the trig function in the equation that you're given, and I'll show you what I mean here. We're being asked to solve for x, where now we've got 2 sine 2x is equal to negative 1, and the domain is simply that x is between 0 and 2 pi. So what's different about this question is this too. Let's think about this graphically for a moment. Before we were being asked to solve 2 sine x is equal to negative 1. And if we want to think of that graphically, it's like asking where does this vertically stretched sine function intersect the line y is equal to negative 1. Well, if we think of this as our graph, so it's a sine function stretching from that's been vertically stretched by a factor of 2 with minima at negative 2, maxima at 2, and it's going to go to 2 pi when it will hit the x-axis again and then repeat from there. We're asking where does it hit the line y is equal to negative 1. And we can see here that on the domain given in the question, it's going to hit twice, there and there. If we were to instead try and solve this equation, the one that we're given here graphically, that would be the same as horizontally stretching this blue function in half so that it looks like this now, and once again asking where does this intersect the line y is equal to negative 1. And you can see, because of that horizontal stretch of a half, it's now going to hit 4 times. We've got twice as many answers as we had before. So that illustrates that there's something going on here that's going to affect the number of solutions we have. So how are we going to deal with that? Well, let's start off the same way as we did before. We're going to move the 2 to the other side by dividing both sides by 2, and then we're going to take the inverse sign of both sides, meaning that we get 2x is equal to the inverse sign of -1/2. Now, this is the spot where we need to pause to think about the domain and recognize that we are going to have more answers than we would have had this only been an x because of this that we described above. The way we're going to handle that is that at the step where you're going to take the inverse sign, you need to come back to your domain. This is a 2x, therefore we need to make the domain match. That means we need to make this x into a 2x. How are we going to do that? Well, to get from x to 2x, you multiply by 2. However, it's connected to this 0 and the 2 pi by this inequality. So to multiply the x by 2, we have to multiply everything by 2. That means multiplying by 2, the 2 pi becomes 4 pi, and the 0 stays at 0, because 0 times 2 is just 0. So what we've done now is we've altered the domain by multiplying by 2. The reason we did that was to get this 2x to match what was in the middle of that domain. Now we do the same thing as we did before, which is we find the related acute angle, and then we work out all of the answers between 0 and 2 pi. And this is the same as the questions we've done above, so it should be relatively straightforward by now. If we start at 0 and we go all the way around to 2 pi, we pick up 7 pi over 6 and 11 pi over 6, the answers we've been getting all along. But now if we go around again to 4 pi, that's another full revolution. And as we saw in the question above, we get 19 pi over 6 the next time round. And we also get 23 pi over 6. Now, those are not the answers for x, those are the answers for 2x. And you can think of this as 4 separate equations. 2x is equal to 7 pi over 6, 2x is equal to 11 pi over 6, 2x is equal to 19 pi over 6, 2x is equal to 23 pi over 6. But what we really want is x. So to get rid of that 2, we're going to divide both sides of the equation by 2. Therefore, we get x is equal to 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. So what we've done is we've taken our original answers up to 4 pi, and the reason that we knew to do that was we changed the domain so that the middle part matched what was the argument of the function, the input of the function. So these go up to 4 pi, but then when we divide by 2, our final answer goes up to 2 pi, which is what we wanted. So that's a little trick where first we go up to 4 pi, then we go up to 2 pi in our final answer. The same kind of thing happens when we've got, instead of a horizontal stretch, a horizontal translation. We're going to deal with that in exactly the same way. We're going to change this x to match the input of the function, x minus pi over 3. Once again, we start off the same way, dividing both sides by 2. We get sine x minus pi over 3 is equal to negative 1 over 2. Therefore, x minus pi over 3 is equal to the inverse sine of negative 1/2. Once again, this is the stage where we look back at our domain and we say, well, they don't match, but we can make them match. To make this into x minus pi over 3, I'm subtracting pi over 3 from the middle part of the inequality. If I've subtracted pi over 3 from the middle part, I need to subtract it from the left and right. On the left, 0 minus pi over 3 is negative pi over 3, and on the right, 2 pi with a denominator of 3 is 6 pi over 3, so subtract 1 pi over 3 from that gives me 5 pi over 3. That means at this stage, when I take my inverse sine, the numbers that, or the angles that I'm going to get on the right-hand side have to fit between these two inclusive. So let's draw my diagram. I know that the related acute angle, as we've seen in all these questions, is 30 degrees pi over 6, and to be negative, to have a negative sine function, we need to be in the bottom quadrants, so I put my pi over 6 there. And now I need to think carefully about where I'm going with this. Let's first go back to negative pi over 3. So if I start from 0 and I'm looking for my first principal angle, negative pi over 3 is going to take me down this way, and I'm going to pick up this angle, which is negative pi over 6. So that's my first principal angle that fits within this domain. So left side stays the same. and I get negative pi over 6 as my first principal angle. Now, if I go to negative pi over 3 or negative 60 degrees, I'm not going to get into this quadrant, so I'm not going to get this angle going backwards. However, if I now go forwards towards 5 pi over 3, I am going to pick up that angle because I get pi, then round to 7 pi over 6, which is the angle we've seen in all these questions. But notice that I'm not going to reach 11 pi over 6 going in the positive or the counterclockwise direction, because 11 pi over 6 is greater than 5 pi over 3. 5 pi over 3 is 10 pi over 6, so I'm going to have to stop when I get to that, and I'm not going to reach 11 pi over 6. 11 pi over 6 is not going to be one of the principal angles. So these are my two answers. Those are the only ones that are going to fit within this modified domain. So those are my answers for x minus pi over 3, but what I really want is x. Let's write this out as two separate equations. What I've got now is x minus pi over 3 is equal to negative pi over 6, and I've got x minus pi over 3 is equal to 7 pi over 6. Therefore, going to the left one, x is going to be equal to negative pi over 6 plus pi over 3. And if we put these into a common denominator, we get negative pi over 6 plus 2 pi over 6. So x is equal to pi over 6. So that's one of my answers. And for this one, x is going to be equal to 7 pi over 6 plus pi over 3. So that's 2 pi over 6, gives me 9 pi over 6, which in lowest terms is 3 pi over 2. So my two final answers are x is equal to pi over 6 and x is equal to 3 pi over 2. Notice that those both fit within the original domain that we're asked for. So that's another example of how you can modify the domain to answer a question when there's some sort of horizontal transformation. Now let's look at how to solve trig equations using a calculator. We're asked to solve for x to one decimal place. 3 cos x plus 1 is equal to 2, and there's the domain given. So we'll start by subtracting 1 from both sides. 3 cos x is equal to 1. Dividing both sides by 3, we get cos x is equal to 1/3. Now we take the inverse cosine of both sides, and we get x is equal to cos inverse of 1 over 3. And here's why we need to use our calculator, because 1 over 3 is not a ratio from any of the special triangles, so we're not going to be able to use those. If we plug that into our calculator, we get that x is approximately equal to 1.231. And make sure your calculator's in radians, because the domain's given in radians, so your answer should be as well. But that's not the only answer, and again, we need to consult the domain to figure out why. 1.231 is less than pi over 2. Remember, 90 degrees is pi over 2. And pi being about 3.14, half that's about 1.57. So 1.57 would be up to the positive y-axis. So 1.23 is going to be there. We're asked to find all the answers between negative pi and pi. If this is 0, this is pi. It's also negative pi going in the opposite direction. So we're missing one of our angles. If cosine's positive, we've got to be in these two quadrants. The missing angle is the one down here, which is simply negative 1.23 radians. Therefore, the answer in the domain that we're asked for is x is approximately negative 1.2 radians or positive 1.2 radians. Again, using the calculator to find the related acute angle, and then using the cast rule and the domain given to figure out which quadrants we're in and what the principal angles are going to be. So that's an introduction to solving trig equations, both algebraically using the special triangles and with a calculator.